In this video, we will learn about quadratic equations. Let's start with the definition of a quadratic equation. A quadratic equation of the form ax squared plus bx plus c is equal to 0, where a, b, and c are all real numbers, and a cannot be equal to 0. So if a was equal to 0, then we would have bx plus c is equal to 0, which is a linear equation and not quadratic. This is also called standard form of a quadratic equation. Now there are three ways to solve a quadratic equation. The first and probably the most popular is factor to solve, or factoring to solve. And that is what we will explore further in this video. A second method is called completing the squares. So completing the squares allows you to get what's called a perfect square trinomial, and from the perfect square trinomial you can solve. A third and also very common method is using the quadratic formula. So there are some advantages and disadvantages to each. First of all, factoring to solve is a very good method. However, not all quadratics are factorable. So if you run into a problem, run into a quadratic that you are trying really hard to factor but can't seem to find the factors, then I might suggest moving on to the other two methods. Completing the squares in the quadratic formula are honestly fantastic methods and can be used to solve any quadratic that exists. Now, completing the squares is actually a method that people or someone at some point in time used to develop the quadratic formula. So in other words, if there was no method of completing the squares, we would not have the quadratic formula. When we factor to solve a quadratic equation, there are a few things we need to do. First, number one, we need to get or set the equation equal to 0. This is really important. So if the equation is not already set equal to 0, you need to do some algebraic manipulation to get it equal to 0. That is the first thing you need to do, and very important. The second thing is you're going to actually factor. And then the third, once you have the factors on the one side of your equation, you're going to use what's called the zero product property. And the zero product property simply is that you set the factors equal to 0 and then solve. So here's the logic behind the zero product property. It says if you have a times b is equal to 0, then here's what we know. We know a must be 0, or b must be 0, or both must be 0. So because of that fact, we can then say, well, let's set a and b equal to 0, or in this case, the factors of the quadratic equal to 0, and see what x has to be in order for them to be 0. Let's practice this, and I'll explain a little bit more as we get into problem number 1. So problem number 1, it's already set equal to 0, so I'm good on the first step, or the first thing to look for, but I do need to factor. So this will be x plus 5 times x minus 5 equal to 0. So this is like my a and this is like my b, meaning the first factor, x plus 5, is my a, the second factor is my b. So if a times b is equal to 0, then we know x plus 5 is equal to 0, and x minus 5 is equal to 0, or x minus 5 is equal to 0. We solve these and we get x is equal to negative 5 and x is equal to positive 5. So both of these are in fact my solution. Typically you'll run into a case where either quadratic equations have one solution, two solutions, or possibly no solution, and that is possible. So in this case it does have in fact two solutions. The second problem, notice how this one does not have what you would call a constant. There's no add or subtracting a constant number. Instead you have the quadratic term and you have the linear term. In this case what you will do is factor the GCF. The GCF happens to be x, so when you factor x you get x minus 8 as the other factor, still equal to 0. you will still set the factors equal to 0 to solve. So x is equal to 0, that's your first factor, and x minus 8 is equal to 0, that's your second. Now there's nothing we can do to solve the first factor, it is equal to 0, nothing we can do to solve for x, it's already solved. The second factor, we solve it and we get x is equal to positive 8. Again, with both of these equations, I highly recommend you go back and check your answer by substituting these back into the original equation and checking. With problem number 3 and number 4, you'll notice that it's slightly different. We don't have a quadratic term, but what we do have is a denominator. And what we will do is clear that denominator by multiplying it by the denominator, so the common denominator. So in this case, what I will have is 6x squared minus 5x is equal to 6. The x denominator cancels out when you multiply that term by x. So now I do in fact have a quadratic equation, and I don't have it equal to 0. So I must subtract 6 to both sides to get it equal to 0. Now I have 6x squared minus 5x minus 6 is equal to 0. From here, you have many different ways in which you can potentially factor this, and to kind of explore your options, I recommend you check out the video for factoring a quadratic when a is not equal to 1. So the factors happen to be when you're done factoring this, whatever process you choose to use, that will be 2x minus 3 and 3x plus 2 equal to 0. From here, we'll set the both factors equal to 0, so 2x minus 3 equal to 0. 3x plus 2 equal to 0, and solve the linear equation. So x will be equal to 3/2, and x in this case will be equal to negative 2/3. With the final equation, we will again multiply by the lowest common denominator. So I'm going to multiply this by x plus 4 and x minus 2. That happens to be my common denominator. With the first term, the x plus 4's cancel out, so I'm left with 5 times x minus 2. With the 4, the second term in my equation here, or the first term on the right side, I will have 4 times x plus 4 and x minus 2. And then finally, with the last term, I have 3 times x plus 4. From here, I need to do some distributing, so I will have 5x minus 10 is equal to 4 times, I'm going to go ahead and distribute the two binomials. So this will be x squared plus 2x minus 8. And then finally 3x plus 12. So from here, I will go ahead and distribute the 4. So I will have 5x minus 10 is equal to 4x squared plus 8x minus 32 plus 3x plus 12. From here, I'm going to go ahead and combine like terms. So I have an 8x on the right side and also a 3. I have a negative 32 and a positive 12. So now I have 5x minus 10 is equal to 4x squared. That will be plus 11x. And finally, minus 20. Okay, one more time, it's not equal to 0, so I need to set this equal to 0 by moving the 5x and the negative 10 over to the other side. So subtract 5x to both sides and add 10 to both sides. So now my final quadratic equation is 4x squared plus 6x, minus 10. Now this one presents a slightly unique problem, you might say, or an opportunity, let's call it that. And that is the fact that you notice with each and every term, there is a common factor that it is divisible by. So we call that the GCF. So what I'd like you to do is factor the GCF, which will make factoring this quadratic a little bit easier. So factor out the 2, and what you have then is 2x squared plus 3x minus 5, and the resulting quadratic is easier to factor given that you have a leading coefficient that is prime and the final constant, which is also prime. Factoring this then gives you 2 times 2x plus 5 and x minus 1. So from here, I'm going to go off to the left here a little bit, or let's just scroll down a little bit. And what you have now, you need to set these factors equal to 0. Now you don't need to really worry about the 2 because it won't really matter in the end, and I can show you why briefly here in a second. But what you have here is 2x plus 5 is equal to 0, and x minus 1 is equal to 0. So then your final answer will be x is equal to negative 5/2, and x is equal to positive 1. Briefly, let me show you what would happen. First of all, you can't distribute the 2 to both binomials. You would only distribute it to 1. So just briefly, I'm going to show you what would happen if you do distribute it to 1. So you would get 0 is equal to 4x plus 10, and then you solve that, you would have negative 10 is equal to 4x, and divide and reduce, and you would have negative 5 over 2 is equal to x. And so what really essentially happens is that by reducing, that 2 becomes not important. By reducing, that 2 cancels out anyway, so we don't really even worry about the 2. So those are my 2 answers, and again, I highly recommend going back and checking your work by substituting these back into the original problem.
A good book is worth melting for.